6.3 is on exponential functions, and so far we've just had linear functions. So remember, back to linear functions, they just formed a line. Well, now exponential functions are going to form something different. So exponential functions, it just means that your numbers are going to exponentially get larger or smaller. So the definition of an exponential function, and again, you don't necessarily have to write all of this, but it is important to note that the kind of formula that you're going to look for is y equals a b to the x power, where a and b are numbers. So you're going to be given the a, you're going to be given the b, you're also either going to be given the x or you have to test some x's. So these are going to be numbers, and this is also either going to be you choose your numbers, or they will give you one and you'll have to evaluate it. But that's kind of the format. Order of operations is important. It's important to do the b to the power before you take it times the a, and I will show you that with a couple examples. So the first thing you might have to do is just be able to identify if it's an exponential function. So first of all, linear functions, remember those make lines, and then we're going to see what happens when you get an exponential function. So first thing is you might be given a chart of numbers, something like this. So it says, for example, 1, and again I would put at least a and b in here so you have an example of each. It says, does each table represent a linear function or an exponential function? Explain. Well, the first thing that you could do to determine is you could just graph it and see, does it make a line or does it not make a line? If it makes a line, you know it's linear. If it doesn't make a line, then it's probably going to be your exponential so far. There are other kinds, but exponential is the next one that we have. So let's look at A. If we're looking at A here, and we can see the solution here, we can see that as our x's are increasing by 1, our y's are increasing by 2. If it's just a like an increase that is constant, that's addition, so addition or subtraction, that's actually just going to make a linear function, meaning if we graphed these points, it would form a line. Now if you look at the next one over here for part B, as these increase by 1, this is increasing at a different rate, but we can use multiplication. So we could say, okay, this is times by 2, this is times by 2, this is times by 2. Well, any time that your y is increasing at a constant rate, it is constant. I shouldn't say constant, just kidding. Not a constant rate, but you can find your pattern, like times 2, times 2, times 2, or times 1/2, times 1/2, times 1/2, or something like that, then this is going to be exponential. So again, if it's adding or subtracting a constant, it's linear. If it's multiply or divide, and we can figure out what that pattern is, then it's going to be exponential. The next thing you might have to do is evaluate an exponential function, and it simply means if I give you the function, like y equals -2, 5 to the x power, and then that says x equals 3. Well, you can see our format, the y equals ab to the x. That's the format that we wanted in, and we've just replaced. So our a is 2, our b is 5, and our x is an x here. So I'm going to take what they gave me, and now it tells me that x equals 3. So it literally means put that 3 up into your equation. So your x is coming out, and your 3 is going in. And now it's just a matter of order of operations. You cannot type in -2 times 5 and raise it to the third power. It will give you the wrong answer. Order of operations say you have to cube it first. So 5 cubed is 125, and then you need to go back and take it times a -2, because you still have -2 squeezed with 125, which is going to be a -250. So when your x is 3, you've evaluated the function, it would be -250. Okay, another example would be if you have y equals 3.5 to the x and x equals -2. So again, fill in the formula, 3.5 all raised to the negative second. Well, 5 to the negative second is like 0.5 times 0.5, which would be 1/4. But when it's a negative, you're going to flip it. You could also just do that on a calculator. So the 0.5 times the 0.5 is going to be 1/4, but flip it, so 4. And then all you have to do is take 4 times, whoops, I wrote that backwards, 4 times 3, which is going to be 12. And again, this is the most important part, to know that order of operations says you have to do this first, then go back and take it times the 3. You have to do 5 times, or 5 to the third power first, then go back and take it times your 2. Okay, the last thing we want to look at is how to actually graph one of these, and I pulled some pictures just from your textbook. This down here is actually what exponential functions look like, and those are two separate ones. Like the blue line would be its own exponential function, and the red one would be its own exponential function. But look what it does. It's a curve to it. So it's not going to make a line. You just put your dots on, and then you're going to have to figure out how to connect those, but there is a curve to the line. So what these two kind of core concepts are showing you is that if your A is a certain number, or if your A is like a positive number or a negative number, depending on what that is, that's what your chart's going to look like, or your graph's going to look like. And then again with the B, but really you don't really have to memorize those. You can just graph it. So if we graph an example, let's figure out what our graph is going to look like here. So here's an example of what it might look like, and it says to graph the function of x equals 4 and then 2 raised to the x. So, and you'll notice this time there are no x's. So the first thing you're going to have to do is make a table of values, meaning test out some points. And I would choose some things like around 0. I would test some positives and some negatives. So I usually choose about 4 just so you can see the line. So let's go -1, 0, 1, 2. And we're going to see what this graph ends up looking like. So after you make your tables of values, you need to test your points. So the points that we chose, -1, 0, and 1, 2, we're going to put those in for x. Okay, those are my x's, and whatever I get are my y's. So I'm going to put up my -1 up here, 2 to the -1, and then I'm going to take that times 4. Well, when I type that into a calculator, I get 2. So we just put a 2 in. When I put 0 in, 2 to the 0 power is 1. 1 times 4, 4. When I put 1 in, and I'm going up here, for all of you are like, where is she going here? I'm putting it into the x. So 2 raised to the first power is just 2, and then take it times 4 is going to be 8. Then do the same thing here. Take your 2 up. 2 times 2, 4. 4 times 4, 16. So remember, your table of values become your ordered pairs. And we're going to go plot these and see what it looks like. From here, I can see this is exponential. Obviously it was exponential because it was in the form, but I can see here that I'm multiplying by 2, by 2, by 2 every time. So let's take a look at what the graph will look like. Okay, so my table of values, my first dot is going to be at -1, 2. So -1, 2, here's my first dot. Then 0, 4, right here. Then 1, 8, 1, 8, and 2, 16. 16 is going to be way up here somewhere. So you can see here that if I connect these, there's going to be a curve. And if I wanted to even go a little bit further and say, okay, I want to know what my next dot's going to be, I could test a -2, -2 raised to the, or 2 raised to the -2 times 4, and you're going to get 1. So then again, I could test that one, -2, 1. You've got a dot here. And actually what happens, if I was to keep going, I'm going to erase our ordered pairs here, you're going to get closer and closer and closer to 0, but you're never actually going to get there. So like it's going to be here, 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 and it's just going to keep creeping towards that line, but it's never actually going to cross it.